Okay, so today we are going to learn how to write and balance equations from a word equation. So they're going to give it to us in the names of the compounds form. So we have to go in our Wayback Machine, not last unit, but the unit before, where we learned how to write the correct formulas and such. All right. So we also have to make sure we're balancing our charges and all that kind of good stuff. So if you're doing this at home, you'll need your periodic table out and your polyatomic ion sheet. All right, starting out with this one. The first thing I like to do is write the symbols right near it, either above it or below it. I don't care. What's the symbol for silver? Ag, very good. And what is the charge for silver? That's one we should know or have written on our periodic table. +1. Then nitrate. Oh, it ends in ATE, so where's that one at? Yeah, well, where do we find that, though? It's on our polyatomic ion sheet, the pink sheet. And NO3 is the correct answer. And what is its charge? -1. So +1, -1, they're going to balance each other out. So we just write AgNO3. Bam. That's the first part. And then it says plus. Hydrogen sulfide. What's hydrogen symbol? H. And what's its charge? +1. And then sulfide is going to be which element? Sulfur. Why do they change anything? I don't know. They just think it sounds better. What's the charge for sulfur off our periodic table? -2. All right. So which do I need more of? H. So I would write it as H2S. All right. And then yields. What's yields look like? It's an arrow. Very good. You can just do the regular arrow. You can fill it in if you really want to. I don't care. All right. And then it says silver sulfide. Well, we already got that. Silver is Ag with a +1. Silver sulfide. Sorry, I said sulfur. -2. Which do I need more of? More silver. So it's going to be Ag2S. Do you see why writing the formulas correctly back in the day was important? And then nitric acid. What do all acids start with? H. And then nitric is going to be which deal? Nitrate, because it's not binary. H is +1, nitrate's -1. Oops, I forgot to put the 3. So we would just write it as HNO3. All right. You will need to have it written correctly before you can balance it, right? Now, if we're going to do our balancing, okay, how many AGs on this side? 1. How many NO3s? Just 1. How many H's? 2. And how many S's? 1. All right, on this side, AGs? 2. NO3s? 1. H's? 1. And S's. Oh, 1. Yep. All right. Is that right? Did I do that right? Okay. So, what do we need to do to get our AGs balanced? Put a 2 in front of this AG. That's going to make that 2. What's it do to my NO3s? Also 2. Remember, if you can, keep your polyatomic ions together. Okay? And then on the other side, AG... our NO3s, what do I need to put over here? A 2. That's going to change my NO3s. That's also going to change my H's. And then so let's look. Oh, our H's are already balanced. Our S's are already balanced. So that's all I got to do, right? A 2 in front of the AgNO3, a 2 in front of the HNO3. Right? Oh. Okay. Now, one thing, guys, because this is going to lead into tomorrow where we start predicting the product. Tomorrow we're going to start where I give you just the first half and you have to tell me the second half. You have to come up with it. All right? So what type of reaction would this be? Double. All right? And we can kind of see that, right? The Ag ends up with the S, right? Positives can't go with positives. Positives go with negatives. So if there's a reaction, it's got to go with the negative from this. The H with the positive goes with the NO3. Does that make sense? That's one of the ways we can do it. So this next one, we're going to kind of do that way, where we just look at the first half and we try to not look at the second half and predict it. Okay, so let's go Papa. All right, zinc. What's zinc? Zn, and what's its charge? +2. Hydroxide. Do you remember what that is? What's that? Zinc is Zn with +2. Yeah, hydroxide's OH with a -1. Right here. We're on the next one. We're going to the next one. Sorry, I just wrote it above so we'd have room down here. Yep, my bad. So Zn is +2. Hydroxide is -1. Which do I need more of? Hydroxide. So Zn. And then hydroxide's a polyatomic ion. If I need more than one, I have to put it in parentheses. And then the 2 goes on the outside. Remember, remember, remember? Okay. Plus phosphoric acid. Phosphoric is going to be which ion? Phosphate. Very good. If we look on our pink sheet, that's going to be what? PO4 -3. And all acids start with hydrogen. H +1. So which do I need more of? Hydrogens. H3PO4. Okay, don't look at the second half. We're going to figure it out from this. Positives have to go with negatives. Right. Okay, so +2. If it's switching, can it go with H or PO4? Which one can it go with? PO4, right? Because it's positive, PO4 is negative. What do 2 and 3 both go into? 6. How many zincs do I need to make 6? Zn3. And then how many PO4s do I need to make 6? PO4, 2. All right? Now, if I put the zinc with the PO4, what's left? If zinc went with PO4, what's left? The OH and the H. All right? This is one of the things, and it's a little easier to see when we do it this way. It tells us water, but because of this, because I have H and OH, don't write water as H2O, write it as HOH. H +1, OH -1. This will make it way easier for balancing it if you write water as HOH. All right? All we did, okay, this is like when we talked about it the other day with reaction types. Everybody switch partners, right? Let me get a little more room so I can show it. Okay? I'm going to flip it to the back side. All right, so we had Zn +2 Zn +2 OH -1, so we had to have 2 of them, right? Are you with me? Okay, plus we had phosphoric acid, which is H is +1, the PO4 is -3. All right? I'm just blowing it up to make it a little bigger. You cannot put 2 positives together, you cannot put 2 negatives together. All right? So if a reaction occurs, zinc can only go with something that's negative. Are you with me? It was already with hydroxide. If we leave it with hydroxide, there's no reaction. So what is the only thing it can combine with that would cause there to be a reaction? The phosphate, the other negative. And hydroxide can only end up with, because they're the wallflowers, they got left behind, right? Hydroxide ends up with your hydrogen. All right? Does that kind of make sense? All right? So then after we've got, and that's why if you have hydroxide and then an acid, write your water on the other side as HOH. It's just, in fact, you could always write as HOH, and if you don't have OH on the other side, you just split it, you got 2 H's, they're just not right together. You know what I'm saying? All right? And then if we go to balance it, Zn, how many Zns? 1. How many OHs? Yeah, we can. Yeah, that's why we do it this way. All right. Her question was on the other side, because it's not like zinc hydroxide, can I still write it as OH? Yeah, that's why I have you write it as HOH instead of H2O. Because let's go ahead and finish this side. We had H, we had 3, PO4, we have 1. All right. On the other side, we have zinc, we have 3, PO4, we have 2. H, so I only have one H if I write it this way. Does that make sense, Lila? All right. Oh, sorry. And I only have one hydroxide. Does that make sense? Okay, perfect. Good question. I really like that question. All right. Now we just balance like before. We have 3 over here. So what do I got to do over here? Put a 3 here. That's going to make that 3. What's it do to my hydroxides? 6. Very good. All right. The PO4s, I got 2 over here. What do I need to put here? 2. Very good. That's going to make my H's 6 and my PO4s 2, right? Now my H's are 6, right? So I go to the other side. What do I need to put here? Just a 6. So now that's 6 and that's 6, all right? So my total answer would be 3 ZnOH2 plus 2 H3PO4 gives me Zn3PO4 2 plus 6 HOH. And if you wrote it as H2O, that's fine too. Guys, I mean, you can do it. What type of reaction is that one again? It's another double. That's actually technically a neutralization reaction. All right. Questions on that before we go on? Nope. Okay. All right. The next one, hydrogen. What's hydrogen? H. Except if H is by itself, how do we write H? H2. Remember, we learned this a long time ago. These elements, H. Broncliffe. Okay? H. Broncliffe. All right? All of these guys, should be written on your periodic table somewhere. If they are by themselves, they'll always be 2. So if it just says hydrogen, it's H2 plus sulfur. What's sulfur? S. Is it one of these guys? So we just write S. Yields hydrogen sulfide. What is the charge of hydrogen? Not sulfur's -2. Plus 1, right? So how many hydrogens do I need? If this is plus 1, sulfur you guys said was -2. I need 2 hydrogens, so H2S, right? And this one's already balanced. Isn't that nice? All right. And then what type of reaction would this be? Synthesis. Good job. Oh. All right. The next one's going to be another double displacement. Okay, that's what I was saying. These elements, and you should have this written on your periodic table. These are, just a second, let me finish explaining this and then I'll go back. All right. These elements, when by themselves, not combined to something else, they can't be alone. They're called diatomic molecules. So if it's just hydrogen, it'll be H2. If it just says bromine, it's Br2. Oxygen's always O2. In fact, if you go to the hospital, a lot of times on the little valve, it doesn't say oxygen, it says O2, right? All of these guys by themselves are 2. All right? Okay, there you go. Back down. And we don't even have to balance it. All right, we'll do one more together. What time do we get out of here? We only have 2 minutes. Okay, I'm going to stop the video.